Right, hi guys. Philip English here from robofeel.com. We've got a gentleman on the line today, Gareth from Senmag, who's going to give us an overview of his technology. And yeah, we'll just have a sort of chat to Gareth and get an understanding of what he's up to. So welcome, Gareth. Welcome
Thank you very much.
to the interview. Could you give us just a real quick overview, of what you do and just about yourself, please?
Okay, so I'm a PhD student at Bristol, and so I work in what we call haptic robotics. So haptic is your sense of touch, and haptic robots are kind of like using your sense of touch as an interface to a computer. So simply what that ends up meaning is you can touch things that aren't really there. So if you've got like a table in virtual reality, you can sort of press down on it and it'll feel solid. So not only can we do just making things feel solid, we can make things sort of springy, so you can have like buttons that click. You can do soft materials and also even textures, make things feel rough and smooth, anything kind of like that.
Wow. Okay. Yeah. I mean, it sounds very sort of like that. That's the way the future's going to go. You put on your headset and then you'll be able to actually physically touch things and feel things. So the fact that you guys are working on that technology is really interesting. So you're over at Bristol we were just chatting earlier. So this is your last year, is that right?
Yeah, so I'm sort of in the last year of my PhD and I've got sort of these robotic systems that are pretty much ready to go. And I'm taking that forward into a startup, which is Senmag.
Right. Fantastic. So at Bristol you're doing what's the name of the degree? Is it robotics and
So PhDs, we just don't really have a name. It's computer science on the degree certificate. But it's kind of like it's anything can fit under the title.
wow.
So sort of day-to-day work is mostly the actual core robotics itself, so motor control and control theory, that kind of thing.
Yeah. And how does it work at Bristol then? Do you pick your own projects? Do you say, "Oh, right, I'm particularly interested in this type of technology," and then is it a group of you, or is it just or you're just on your own and you do your own thing, or you as a team?
So it'll vary a lot between people. Like some people have a lot of kind of so they'll be in a team and they'll have like a role within the team being pushed into what they're doing. Myself, I've been very lucky having a supervisor who's very free rein with me.
Okay.
So I get a lot of freedom in choosing the direction I want to go down. And my supervisor kind of helps me work out the academic side to that.
Wow. Okay. And then why did you pick this route? Because obviously we've seen quite a lot of things from Bristol, like robotics, with a mixture of different products. And this I really like. Was it a passion to do with VR? Was it, or was that?
Yeah, absolutely. So when I first sort of encountered this technology, that force feedback haptic stuff, as an undergraduate, so when I was going around doing open days, I saw these at a university, and it was like, you ever try the Rift DK1? It was like that kind of moment of just like magic, just like, what is this? How does it work? kind of thing. And it's like I was an instant believer in the tech, and it's like I wanted to work on it. Um, so did my major project in my undergraduate degree working on the kind of haptic technology stuff and carried it forward into a PhD and still going.
Still going, yeah. No, yeah. I mean, again, I think you've definitely got that's definitely where the future's going, really. For that sort of tech. I mean, we've all seen the films with the game. What's the game by Steven Spielberg? Sorry, the film by Steven Spielberg. If I say his name. Um,
the Ready Player One maybe?
yeah, that's the first
Yeah.
thing. Yeah, it's the first thing that I think about when I see this sort of technology. Um, so I suppose if we go to sort of the problems that your technology solves, so I guess in a 3D world, obviously you can see what's going on, but if you wanna get some real reaction and engagement from people, then you want them to be able to feel and touch. I mean, is that the main sort of problems it solves? And
Yes, I think there's two sides to it. So whenever we're talking about anything in computers, right, there's the side where you're consuming the content, which is like when you're playing a video game or watching a film, that kind of thing. But there's a whole other side, which is where you're creating the content, right? So whenever you've got a video game, someone's had to create all of those models. Now, I think as kind of our platforms that we're using are moving into things like VR and AR, the way that we're going to have to create this content is going to have to change. along with the platforms.
Okay.
So if you think about now, when you see an advert on your screen, it's a 2D image, right?
Yeah.
But how does an advert in a VR environment look? Is it still 2D or is it going to be a 3D thing?
Yeah.
Like, I think to actually utilize the benefits of the new platform, a lot of the content we're creating is going to have to move into 3D to suit it.
Yeah.
And that opens up quite an interesting question to how do you create this kind of new 3D content? So anyone who's done anything like 3D CAD a lot, when you're trying to work with 3D objects using 2D interfaces, like, a normal screen is 2D, keyboard and mouse, 2D kind of things, like that kind of translation doesn't really work very well. And there's a whole market of these things called space bubbles, which are just for orienting your view in 3D.
I've seen those things, a twist.
Yeah.
Yeah.
So it's all about just getting around that one problem. So I think there's going to be a lot of interesting things in looking into how we actually create the new wave of content for VR and AR. And I think things like this that naturally work in that environment, naturally work in a 3D environment, are probably the way forward for it.
Wow. And I suppose as it develops, then it could get ultra sensitive, as in that you can actually really start to train people with that sort of tech. And I suppose it's a bit like the films where you almost you can train someone to a physical level using that technology before they go out and do it in the real world. So
yeah, so one of the real powers about it is the intuitiveness of the sense of touch. So when we're young, like, touch is one of the first things we learn, right? So one thing that's really interesting is when the GUI, the first GUI programs, they really exploded the use of computers just because they were so intuitive, right? Anyone can pick one up and point and click at things.
Yeah.
We see that again with touchscreens and smartphones, right? Even our grandparents can work out, point and click on a smartphone.
Yeah.
So I think there's a real thing about intuitive interfaces that a lot of the current things kind of aren't quite working. And I think when we sort of move into this 3D space with 3D interactions, that's going to be very interesting for how it affects human creativity in all spaces.
Yeah, well, this is it. I mean, it's the reaction there. So I suppose your solution, if we go through that, so you're building it out of 3D parts. Is that right at the moment, or?
Yeah. So what it essentially gives you is not only a position in 3D, so you can move around in 3D. It gives you interactions in 3D. So you can put stuff into the 3D environment and it can sort of push back at you.
Right.
So it's kind of like it gives you a real physical presence in this VR world where the rules are code.
And then how much force can it push back, or does it depend on how well the 3D device is made?
Yeah, so it does completely depend on the device. The ones we're showing can do about a kilogram.
Right.
So for a fingertip, that's probably, we think, about a good ball range to go for, because it's not enough to tear your finger off. Is the main thing. So it's plenty enough to feel something substantial on the end of your finger, like it's enough to make things feel solid, but not enough to be dangerous.
And can you pick something up there, or is it at the moment it's just about pushing it or feeling it?
Yeah, so we've done, so the actual devices that we're doing were designed as a dual device. So the videos I'll show you is just the one on its own.
Perfect.
But you can sort of hook up two of them at the same time, have one on the finger, one on the thumb, and pinch things, pick them up, throw them around.
Okay.
So it's really kind of this, it's a really low level thing it actually gives you, this kind of physical presence. And the sort of flexibility you get from it is what you can imagine to program with it that you can do, right?
Yeah. So it's the starting point. I mean, I think as we were chatting earlier, I saw you at one of the shows in Milton Keynes, and I think I had a quick go, and what I saw was you had a round ball and a square. Was that was that what you currently have, or is there lots of different things that that you can move around?
So there's a few things we can do. So at the minute, as far as we've got is we've hooked it up with Unity. So you can work directly in Unity. You can drag and drop a cube into it and it will work.
Right.
So we built up a few demos on that,
And then
but it's all working with the inbuilt physics engine.
right, and then Unity. Sorry, I don't know what Unity is.
Okay, so Unity is so it's for developing video games. It's
Right.
essentially like or anything 3D graphics, but it's kind of like it's a really nice intuitive program for just creating things.
Right, I see. Okay, so you developed into that, so it makes it easier to create different like objects that you actually want.
Absolutely. So the whole kind of the approach I'm doing is trying to make the force feedback stuff really accessible, really easy for people to just create stuff with. So I think the trouble at the minute is because I think there's such a vast scope for where it could be useful.
Yeah.
It's too much for me to think about even. So the approach I'm taking is try and make it easy for as many people to work with as possible and see what people come up with.
Right. I mean, is it possible to sort of download a 3D kit then and print it on the 3D printer and build something similar, or is it not that level yet?
So it's a bit difficult. So the actual physical parts could be 3D printed. The tricky stuff is all the electronics and the motor control and stuff that goes behind it to make it work.
Yeah.
So yeah, it's probably not anytime soon something that anyone could build at home, the robot itself. But to buy a robot and use it is what we're trying to make easy.
Right. And then I suppose where do you see the first users of this? I mean, do you see it sort of in the industry space or a health space, or have you got plans to sort of to build one in that's doing a task that's live?
Yeah, so there's kind of like a few application spaces that I immediately see for them. One big one will be telerobotics.
Yeah.
So quite often, if you've got like a hazardous environment that you're working in, you don't want to send a human into that environment. So if it's a nuclear reactor or something like that, you can't have a human in there.
Yeah.
But at the same time, you don't necessarily want to rely on a bit of code to perform the task.
Yeah.
So you want the human intelligence there, but not the human presence. And a way of getting around that is to send in a robot, which is controlled by one of these devices.
I'm with you. Yeah, I mean, I've seen a lot of news about when we sort of cross over into more of a robotic world that there's going to be a bit of a half-half thing where you're going to have a lot of people who are going to be in control of robots. So instead of just having like a robot in a mall that's going around and you just tap on the screen, that you actually have that would be connected to someone sitting at home or sitting in an office, and you can actually have a face-to-face conversation, and then the ability to help people out with stuff. So yeah, that makes sense.
Yeah, absolutely. Yeah. So I think there's going to be a lot of applications in kind of things like the nuclear industry and in particularly space stuff. Actually, I think would be interesting. So you see videos of astronauts going out on spacewalks to do basic maintenance kind of tasks, and it's probably quite a dangerous thing to do, really.
Yeah.
If you could send a robot out instead, that'd save a lot of time, right?
Yeah. And then have you tried the technology with any of like the cobot arms that are out there right at the moment? Is it possible to code something like that? Well, I suppose you would need some sort of sensor, wouldn't you, on the arms, so you can figure out what it's picking up.
Yeah. So it's the robots themselves. They throw out the position in XYZ, and you can do anything with that.
Yep.
So it's very easy to hook up to pretty much anything. Like one of the cobot arms would be theoretically fine to do. So the thing is you need to give that feedback of feeling what you're actually doing. As you say, you need to put sensors on the cobot.
Okay, and have you seen any sensor stuff that's come out recently? I mean, I know I've seen the cloth ones where they put a cloth over the robot, and the cloth has got a sort of sensitivity to it. Is that something that you could possibly merge in with your tech, or is it a completely different type of technology?
So it's kind of it's is in like a neighbouring field, I'd say. So within the sort of term of haptic feedback, you've got kind of two sub-camps within that, which are, we call them kinesthetic, which is forces, so making things feel hard. And then you've got the tactile, which is kind of on-skin sensations. So if something feels rough or smooth, that's more tactile.
Yep, I'm with you.
Now, things, sort of things like cloth, like it sounds like, is probably more towards the tactile side. So it'll be more for recognizing textures, feeling around the shapes of things. So whereas the best way to do it would be to combine both. So you need both the tactile and the kinesthetic components. And that sort of makes up the full sense of touch.
Full sense of touch, yeah. Wow, okay, okay. Yeah, I mean, I think, I mean, so as you were saying about the space, you know, the spaces and the nuclear field is the place to go. So have you got like a well, I suppose a timeline or like a vision? I mean, as you were saying, like the possibilities could be endless, really. I mean, from basic tasks of us, you know, doing like office tasks all the way up to space. So I suppose if you can build that platform, and then you can just implement it into many different industries. Is it that easy to actually build a module? I suppose no. I suppose, you know, to actually. I mean, what's your sort of dream plan to say to, you know, to actually get it out there to more people?
So, well, the hope is that we'll eventually, so we'll have something to sort of start in, like an industry to get us going.
Yeah.
And then we'll be able to sort of focus our designs on something a bit more generic as such. So I think the trouble with these kind of robots is they're not going to be cheap enough for your everyday average consumer to, you know, play their video games with.
Yeah.
So I think there's going to be, they're sort of a bit more of an experiment into the space at the minute. So I think mass markets will come later once we understand what bits we need and what bits we don't.
Okay.
But I think for now there's also applications within a lot of the 3D design space as well. So people who are doing 3D CAD and working natively within the 3D environment is something we could do now. And I think that's another big application space as well as the telerobotics stuff. But in future, I think it's definitely is talking about this idea of reimagining how we interact with our digital spaces.
And then would it be more? Again, I'm not thinking a bit out over the top here, but would it be more of like a suit then? Because obviously I know from the videos that we show, you've got the fingers. So would it be a glove that you'd put your hands into, and then essentially then it would go up and around, and it'd be more and more something that you would wear to control something?
Yeah, so I think this is about looking into the understanding behind what it is we do need and what it is we don't need in this tech. So the trouble is the more parts you add, the more it's going to cost in the end of the day.
Yeah.
So if you're trying to build essentially a robot around your body, that's a lot of motors, that's a lot of electronics, all that kind of stuff. So I think in terms of actual force generation, I'm not sure there's many application spaces that could afford that kind of full body thing. So I think in terms of doing full body stuff, I'm expecting a lot more tactile stuff rather than kinesthetic. So tactile you can do a lot easier. So with the vibration motors, that kind of thing, it's much easier to stick a load of vibration motors over you than to build an exoskeleton around you.
Right, I see.
So I definitely see the sort of future of full body stuff being in more the tactile area.
Yeah.
But that's something we'll be exploring.
Yeah, I mean it's like you said, like you need if you have a specific task, you know, the good example is a nuclear task or something where you need that level of sensitivity to feel what's going on. Yeah, no, it's a great product, and I think this is definitely where the world's sort of going with that type of technology. So I'm looking forward to see how things like develop, really, you know, and keep an eye on you. I mean, what's the best way to find you, Gareth? What's the best way to get in contact?
Okay, so we've got a website which is senmag-robotics.com. There's not much on it at the minute. We are working on updating it, but you can put in your email on there, send us a message, and we'll get back to you and keep you updated. Yeah,
Fantastic, fantastic.
it's the best way.
Okay, no, that's great. Thank you, Gareth. Well, guys, what I'll do is I'll put those details down, so you can get in contact with Gareth. And yeah, no, like, thanks very much for your time today, Gareth. It's been
So,
very interesting.
thanks for having me.